This is Euclid Book 3, proposition number 15, and we're going to start with a circle. And it's going to go from point A to point M to point F to point G to point N to point D to point C and back over here to point B. Okay? Now then, we're going to draw the diameter of the circle. To do this, we have to first figure out where the center of the circle is. And we can do this with Euclid Book 3, proposition number 1. And we find it at point E. And then we're going to draw a line from point A to point D that's going to pass through point E. And that's going to be the diameter of the circle. And then we're going to draw two other lines. We're going to pick point B and point C here. We're going to draw a line that connects those 2 points here. And then we're going to draw a line from point F to point G. Okay? And FG, this line right here, is going to connect points F and G on this circle. Now then, we're going to prove that AD here, this is AD, it's going to be the longest line that you can draw between 2 points on the circumference of a circle. Now, any line that you draw between 2 points on the circumference of the circle that isn't a diameter, when it gets closer to the center, it's going to be bigger in size. In other words, line BC is going to be bigger in size to line FG here because line BC is closer to E than line FG. Okay? Now, the first thing Euclid wants you to do is he wants you to draw a line from point E to point H and another line from point E to point K. Now, EH and EK are going to be perpendicular lines. EH is going to be perpendicular to BC, and EK is going to be perpendicular to FG. Alright, so far so good. Now, we're going to draw some other lines. And when we do, we can say that EA and EM and EF and EG and EN and ED are all going to be equal in size because they are radii of this circle. Okay. Now, by using Euclid Book 3, definition number 5, we can say that EK, which is right here, is bigger in size than EH. Okay? And then we're going to say that EL, wherever EL is, we're going to draw a line from point E to point L. And we're going to draw another, we've already drawn the line from E to H. We're going to draw another line from E to L. And we're going to say that line EL and EH are equal in size. Okay? That's a given. And then we're going to say that line MN, this is line N, this is point M, this is point N, there's going to be a line that connects the two. It's going to be perpendicular to EK. And by doing so, MN is at right angles to EK. Okay? So MLE and MLK are going to be right angles, and ELN and NLK are going to be right angles as well. All right. By Euclid Book 3, proposition number 14, we can now say that line BC here is equal in size to line MN here. All right. Now, we already now know that if you were to add the length of EM and EN together, you would get a total length exactly the same size as AD. Because remember, AE and EM are equal in size, and ED and EN are equal in size. So if you were to add AE and ED together, you would get the same size as EM and EN. Alright. The sum of the sizes of EM and EN, here's EM here, here's EN here, those sizes added together would be longer than MN. MN here. Alright, the length of MN right here is equal to the size of BC. We've already established that by Euclid Book 3, proposition number 14. Therefore, if AD is longer in size than MN, then AD is also going to be longer in size than BC. Now, the angle MEN is going to be greater in size than the angle FEG. You can pretty much see this for yourself. All right. Now, the length of MN, this is MN here, is going to be greater in size than the length of FG. And this is because of Euclid Book 1, proposition number 24. Now, we already know the length of MN is equal to BC. And we already know that AD is bigger in size than BC. So BC is also bigger in size than FG. Okay? Now, we already know this because if MN is bigger in size than BC, and MN is bigger in size than FG, then BC is also going to be bigger in size than FG. And that's all Euclid wanted you to prove. And you've done it. I will tell you more in a future video, so stay tuned.